everyone. So today I'll be discussing question number 51 of Set 2 GATE Civil Engineering 2022. The linearly elastic planar structure shown in the figure is acted upon by two vertical concentrated forces. The horizontal beams UV and WX are connected with the help of a vertical linear spring with a spring constant K 20 kN per meter. The fixed supports are provided at U and X. It is given that the flexural rigidity EI is 10 to the power 5 kN meter square, P is 100 kN, A is 5 meter. The force Q is applied at the center of the beam WX such that the force in the spring VW becomes 0. It's a 2-mark question of fill in the blanks type with no negative marking. Please note that the magnitude of force Q should be given in kilonewton. For these type of problems, you can refer to lecture series on strength of materials by Professor S.K. Bhattacharya, Department of Civil Engineering, IIT Kharagpur. Now let's move towards the solution of this problem. The things which are given to us in this problem are the value of K, that is 20 kN per meter, the flexural rigidity EI, that is 10 to the power 5 kN meter square, the value of load P, that is 100 kN, and the value of A, that is 5 meter. Before starting the solution, let us discuss the key concept of this problem. So in this problem, it is given to us that the force in the spring is 0. From this formula F equal to K delta, we can infer that if the force in the spring is 0, this implies that deformation of the spring is 0. So let's see in what case the deformation can be 0. So suppose this is the applied load P and this is the applied load Q. Let us see how the beam will deform in both the cases. So the first beam will deform something like this. The second beam will be curved up till the point of application of Q and will be straight line after that. We'll discuss this later also in the later part of this problem. So suppose this is called as delta V and the deformation of this beam is called as delta W. So let's draw a spring also. So these two beams are connected with a spring. So we have drawn a spring also. So in what case this spring can remain undeformable? The only possible case is when this delta V, that is the deflection of beam, first beam, that is this beam, should be equal to delta W, that is the deformation of second beam at point W. So if delta V is equal to delta W, this implies that this spring will remain undeformable. So we will calculate the value of delta V and equate it with the value of delta W, and we will find our value of Q. So this is clearly a problem of deflection at a point due to applied point load for a cantilever beam. So how to calculate the value of deflection? There are many methods to calculate the deflection at a point in a beam due to applied point load, but for GATE it is recommended that you should remember some standard formulas to solve the problem quickly. You can refer to the deflection of beam lecture by Professor S.K. Bhattacharya in case you want to see the detailed derivation for this problem. For this lecture, I'll be solving this problem using the standard formula. So what is the value of deflection when a point load is applied at the free end of the cantilever beam? The beam will deflect like this. The value of this deflection delta and the value of this slope theta will be the value of deflection delta will be the applied load, that is P, the length of the beam, here it is L, PL cube by 3 times of the flexural rigidity of the beam. What will be the value of theta? The value of theta, that is the slope at the free end, will be P, that is the load, length square divided by 2 times the flexural rigidity of the beam. So these two formulas we should remember for solving this problem. Now let us use these two standard formulas to quickly get our solution. Consider the first beam. So how will this beam deflect under the point load? The beam will deflect like this. So here we can simply use the standard formulas we have noted down earlier. So the value of delta V will be simply load, that is P, length cube, here the length is 2A, by 3 times of the flexural rigidity of the beam. Here the flexural rigidity is EI. So we simply get a value of delta V as 8PA cube by 3EI. We are intending to get the value of Q finally, and for that our condition is delta V should be equal to delta W. And we have already calculated the value of delta V by now. Now we will look how to calculate the value of delta W. For that, let us consider the second beam. So how will this beam deflect under this load? So the beam will deflect, this will be curved till the point of application of load Q, and after that it will be a straight line. Why it will be a straight line after that? Because the no load is applied after that point of application of Q. So how will we calculate the value of delta W? So the value of delta W will be the sum of 2 delta, that is delta 1, let us name it as delta 1, and let us name it as delta 2, right? So what is the value of delta 1 and delta 2 now? So it is, let us suppose it is theta, so it will also be theta. Now what is delta 1 here? Delta 1 is simply the load, that is a deflection due to this point load Q, and it will be like our standard formula. It will be load, that is Q here, length up till here is A, because we have to calculate this thing which is delta 1. So A cube by 3 times of the flexural rigidity of this beam. This beam has a flexural rigidity of 2EI. Okay, so this is the value of delta 1. What will be the value of delta 2? The value of delta 2 will be simply theta multiplied by L. Theta multiplied by this length L, which is A in this case. So the value of delta 2 will be theta multiplied by A. We know that the value of theta will be, from the standard formula, it will be P, here it is Q, length up till here is A, square by 2 times of the flexural rigidity of the beam. The flexural rigidity of this beam is 2EI multiplied by A. So now we know the value of delta 1, and we also know the value of delta 2 now. So let us calculate the value of delta W now. Delta W is simply delta 1 plus delta 2. Delta W will be equals to, what is the value of delta 1? Delta 1 is QA cube by 6EI. And delta 2 is QA cube by 4EI. Okay, so finally what will be the delta W? Delta W will be 10 QA cube by 24 EI. Right? So now we'll equate the value of delta V and delta W to finally get our value of Q. So let us equate them. What is the value of delta V? Delta V is 8 PA cube by 3 EI. 8 PA cube by 3 EI. And what is delta W? It is 10 QA cube by 24 EI. After solving this, we get the value of Q as 64 P by 10. And what is the value of P? It is given to us that P is 100 kilonewton. So the Q will automatically in kilonewton. So value of Q will be 640 kilonewton. So this is what we have to calculate. So we have the solution now. The value of Q is 640 kilonewton.